Hello everyone, my name is Kexin Yang. I'm a second-year PhD student in Human-Computer Interaction Institute at Carnegie Mellon University. Today I'll talk about our work on exploring teacher-guided crowdsourcing for improving hints in an AI-based tutor. AI-based educational software is increasingly used in K-12 classrooms and can reach teachers and students across a broad range of educational contexts. And they may be most welcome in classroom when they align with the teacher's goals, preferences, and instructional practice. For example, in a prior study, they investigated the needs for K-12 teachers who use AI-tutor in their classroom. Holstein et al. Found that teachers may discontinue the use of AI-tutor if there is a misalignment between instructional materials in the software and their current curriculum in use, especially if there are no convenient way for teachers to customize the content. The current paper takes inspiration from this prior work, which uncovered a critical teacher's need. When using an AI tutor in the classroom, teachers often find the particular on-demand hints to be insufficiently helpful for their students. In turn, teachers desire a simple way to revise these hints for the benefit of future students. In co-design session with teachers, they envision mechanisms to provide rapid feedback to the AI tutor even during an ongoing class session, as soon as a complaint about a particular hint arises, with minimal interruption of the teacher's teaching activities. And our study takes context in an AI-based tutoring system, the NET, which offers guided practice to middle school students. And our workflow focuses on improving these on-demand hints in the software. And when using the AI tutor, students can ask for hints when they get stuck, and hints of this type are given by the system at students' request. The hints suggest what to do next and explain why this is a good thing to do in terms of the underlying problem-solving principles. Despite the need we described, prior work has not found a scalable, time-efficient way to enable stakeholders to customize instructional materials in AI-based software. The current state-of-the-art method for generating educational content is through manual authoring by domain expert or instructional designers. While involving teachers in the material authoring process can be effective, one challenge is that teachers, like other experts, tend to have very limited time for these activities. Thus, crowdsourcing holds the potential to be a cost-effective and scalable way to meet this need. Minimizing expert involvement is an important issue not just in education, but in other crowdsourcing task domains as well. Prior study has showed that crowdworkers can generate reasonable quality of instructional materials for K-12 math. However, less is known about whether or not the crowdworkers could succeed in content revision, where they must improve upon existing materials. Our main research question are these three following questions: whether or not our pipeline of this expert-guided crowdsourcing can work, and whether or not the teacher customization of the hints is needed or necessary, and whether what kind of challenges will this kind of pipeline encounter. We conducted 2 experiments where we explored the first version of a teacher-guided crowdsourcing pipeline, aiming at improving and customizing instructional materials to a higher expert stakeholder satisfaction while minimizing the time they put in. We now introduce our different stages in this pipeline. In stage 1, teachers would read, rated, and commented on 5 sets of existing AI tutor hints presented in a random sequence. After reading, rating, and commenting on the existing hints, teachers would then generate their own preferred hint revision for each problem state, as well as completed 4 open-ended questions on their preferences of how AI tutor hints should be authored. In stage 2, crowdworkers would read this teacher's guidance, and based on the guidance, crowd would list out changes to make and mirrors to keep in the existing hints. In stage 3, M-Turkers would write and revise the hints for each of the 5 problem states. And in stage 4, we have implemented a stage for quality control of crowd work, where M-Turkers will rate the crowd-generated or the crowd-revised hints on 3 dimensions, respectively, mathematical correctness and accuracy, ease of understanding, and effectiveness in helping students learn. Our participants mainly involve teachers whom were recruited from the teacher social media group and M-Turkers who are US-based and has an approval rate of hit of more than 98%. In study 1, we compare teachers' rating for hints under each condition. Condition 1 is where M-takers would receive no existing hints or teacher guidance and write hints from scratch. And condition 2 is where M-takers receive multiple teachers' rating of existing AI tutors' hints. And condition 3 is where M-takers receive multiple teachers' rating and comments on existing AI tutor hints. Condition 4 contains hints written by randomly selected teacher expert, and condition 5 contains the original hints in the AI tutor. We have found that the crowd revision did not have significant improvement over the original hints. We further analyzed whether or not teachers' hint preferences converge or diverge on 4 aspects. As shown in the upper part of the picture, teachers were relatively aligned in their preferences for conceptual hints over procedural ones, and their preferences for hints that can adapt to student strategies. As shown in the bottom part of the picture, teachers also have more divergent preferences on the 2 other dimensions, such as how long should a hint be and whether or not hints should contain bottom-up answers. Since we found teachers can have varied, highly specific, and even conflicting hint preferences, non-customized generic fixes may not cater to everyone's taste. We thus conducted study 2 to investigate whether customized hints by crowdworkers can lead to better teacher satisfaction. The workflow in study 2 largely emulates study 1, and the main difference is that in study 2, each crowdworkers receive only 1 teacher's guidance, instead of multiple as in study 1. Our main goal was to compare teacher satisfaction on crowd-customized hints, existing AI tutor hints, and teachers' own revised hints. From these 2 studies, we have found that generating minimal guidance for crowds can take teachers less time than revising the hints themselves, indicating that the minimally guided crowdsourcing pipeline has the potential to save teachers time. However, we also find that with this minimal guidance, the crowdsourced pipeline generates hint revisions that did not really improve over the original hints. But what is worth noting is the crowd-revised hints are better than the 2 comparison conditions, namely the hints written from scratch by the crowd and also the randomly selected teachers' written hints. In addition, in study 2, we found that teachers strongly prefer their own revision over other revision, and also they would rate their own revision as improvement over the original hints. We conducted some qualitative analysis and data triangulation on teachers' complaints on different hint sources. We found the main challenges for the crowd lies in understanding the expert brief written comments and in implementing them in forms of effective edits without raising new expert concerns. Teachers indicated that hints revised by crowdworkers tend to introduce new issues in terms of clarity, inconsistency, and inaccuracies. And future pipelines targeting revision tasks should implement additional scaffolding to prevent these issues. In sum, we contribute a study that experiments with a minimally expert-guided crowdsourcing pipeline for content revision. While we focus on addressing a practical need, the research provides insights into the broader question of how minimal expert guidance can be in scaffolding complex crowd work. Specifically, we found that the 2 forms of minimal expert guidance explored in this work are effective only to a degree. And we contribute analysis where additional scaffolding are most needed. We outline a number of specific challenges that future expert-guided crowd revision pipeline may need to overcome. And this work also yields new insights into teachers' needs regarding customization of instructional materials, which could be applied to create a more effective expert-guided revision crowdsourcing pipeline in and beyond mass education context. Thank you.